Okay, so I'm looking at number 5 on the review. I'm going to be doing parts A and D, and I'll leave B and C to you. Um, we're trying to find a polynomial with the following zeros and a leading coefficient of 2 that's degree 3. Okay, so first of all, zeros are the places, like the x's that you plug in and you get 0, right? A leading coefficient is the number in front of the highest power of x. Okay, so in this case, the number in front of the highest power of x is 2, and then the degree being 3, the degree is the highest power that's on the x. Okay, so in this case, what we are going to be doing is, well, I know the zeros, so I know what the factored form is going to look like. So it's going to be something like, well, to have a 0 of 1, I've got to have an x minus 1 as a factor, right? To have x equals 2 as a 0, I've got to have x minus 2 as a factor. And then finally, oh, sorry, I didn't mean to do D here. I meant to do, we'll do C. Okay. And then for this 0 here, x is negative 4 will mean that x plus 4 has got to also be a factor. Okay, so that covers these as being zeros. Okay, a leading coefficient of 2 means that the number in front of the highest power in x needs to be 2. So you can just throw a 2 out front of this polynomial, and that will give you the polynomial. And then if you check, like, you could multiply this all out to get the actual equation for the polynomial, but when you do x times x times x, you're going to get x cubed, right? And that's the biggest power on x you can have, so that's the degree. So this is the right polynomial. This would be the polynomial that satisfies that. I think on the key they multiply it out. I don't really care if you multiply it out. You can just leave it like that. It's fine. Okay. So hopefully that helps with that. Let's look at C now. So we've got zeros, x equals 2, x equals negative 2, x equals I, degree 4, and p of 0 is 8. Okay, so we're looking for a polynomial with all of these things. Okay, so let's start by getting our zeros to be right. So what we're going to have here is, to have a 0 of 2, we've got to have an x minus 2 as a factor. To have x is negative 2 as a root, we've got to have x plus 2 as a factor, right? X minus I, we've got, or sorry, x equals I is a 0, we've got to have x minus I as a factor. Now this is something that you do need to remember when you have complex solutions for a real coefficient polynomial. The complex conjugates are also always roots. And it actually gives you on this one that negative I is a 0. I didn't write it up here because I wanted to talk about this, but even if they didn't tell you that negative I was a 0, you would know that it is because I is a 0, okay? And that's because this is a real valued polynomial, and so whenever you have a imaginary solution, one with I in it, if you switch the sign on the I, that will also be a solution, okay? So we're also going to have x plus I will be in this factorization, okay? And now you'll notice we have degree 4 because we've got x times x times x times x. So 4 x's times each other is x to the 4th. And so we've got the right degree. Okay. The only thing we have to worry about now is this p of 0 is 8. Okay, how do we get that to work? Well, if you kind of remember over here, to adjust the polynomial at the end, we needed a 2 in front, right? To be able to get this leading coefficient to be what we want. We can always throw a number on the front of this, like we'll call it A maybe. We can always throw any number we want on the front of this, and it won't change the zeros, right? This will have the same zeros because it's still factored out. And so if we figure out what A we need to have to make this 8, this whole thing 8 at 0, we can go from there. So what I would do is I would plug in 0 and set it equal to 8. So 8 equals A times 0 minus 2, 0 plus 2, 0 minus I, 0 plus I. Okay. And so when we do this out, we get 8 equals negative 2. So A times negative 2 times 2, and then negative I times I. So we've gotten 8 is negative 4. A, and then negative I times positive I, this is negative I squared. If you remember, what is I squared? Well, I squared, by definition, I squared is negative 1 because I is the square root of negative 1, right? So I squared is negative 1, so negative I squared would be positive 1, okay? So that's just positive 1 there, so negative 4A is equal to 8, so then A is equal to negative 2, okay? So that's the A that I need for this to equal 8 when I plug in 0. So I would just replace that A with negative 2. And then this whole polynomial, including the x plus I there, that I couldn't fit on that same line, this would be your answer, okay? And I don't necessarily care that you multiply it out. You can just leave it like that is fine, okay? Okay, so hopefully that helps with that. One thing I do want to mention, I'm not going to do the other two parts on this, but on part D of this, they talk about multiplicity, okay? And so if it had told me here that x equals 1 had a multiplicity of 2, if they had said that this one had a multiplicity of 2, that would just mean that I would put a 2 as the power on the x minus 1, right? So multiplicity is how many times the root is repeated, or like how many times that factor is repeated in the factorization of the polynomial. So hopefully that covers all your bases there. Good little review of writing polynomials with specific roots.